Hello students, this is Professor R.M. Mahindrakar from JSS Arts, Science and Commerce College, Gokak. The arrangement of biotic components of the food chain according to their size, metabolic relationship is known as the trophic structure. This relationship between the various trophic levels of a food chain, that is the producers, herbivores and carnivores, can be shown diagrammatically. This graphical representation of the relationship between the different organisms in an ecosystem, which assumes a shape of a pyramid, is called ecological pyramid. So in today's presentation, we'll be studying about this ecological pyramid. Now in ecological pyramid, each bar that makes off the pyramid represents the different trophic levels. Now let us study the structure of the ecological pyramid. Ecological pyramid begins with the producers at the bottom. So the base of the pyramid is always occupied by the producers, which include the plants, that is all the autotrophic plants, and also the chemotrophic organisms. So they form the first trophic level. The second trophic level is occupied by the primary consumers. These are all herbivores, that is the animals which eat the plants. Then the third trophic level is occupied by the secondary consumers or the primary carnivore. These secondary consumer organisms feed on the herbivores. The fourth trophic level is occupied by the tertiary consumer or secondary carnivore. And the top of the pyramid is occupied by the top consumer or the top carnivore, which forms the top of the food chain. There is some sort of relationship between the number, biomass and energy content of the producers and consumers of different orders in an ecosystem. These relationships, when represented in a diagrammatic way, are referred to as the ecological pyramid. And these are of following three types, that is, the pyramid of number, the pyramid of biomass, and the pyramid of energy. Now first let us study the ecological pyramid of number. The first attempt to provide a quantitative law concerning the trophic levels was given by Alton in the year 1927, who coined the term pyramid of number. The pyramid of number deals with the relationship between the number of primary producers and consumers of different order. In all cases, the base of such a pyramid is always represented by the number of primary producers, and the subsequent structures on their base are represented by the number of consumers of successive level. The top representing the number of the top carnivore in an ecosystem. The shape of the pyramid may be upright or inverted. Now if you take a grassland as an ecosystem and study the ecological pyramid of number, we always get a erect pyramid. Now here you can see this is a cropland. Now here if you see the number of the plants are always more, hence the base of the pyramid is broad. So the producers are large in number, hence their first trophic level is always broad. Then these crop plants are eaten by these grasshoppers. The number of grasshoppers in the crop field are comparatively less, hence the base is slightly narrower. Now these grasshoppers are eaten by the frogs. So here their number is less, hence the third trophic level assumes a smaller size. Then these frogs are eaten by the snakes. The snakes are still lesser in number, and hence the fourth trophic level size also will be a narrower one, and the top of the pyramid is occupied by the hawk, which feeds on the snakes, and they are still less in number. Thus, if you consider this cropland as an ecosystem, now here you'll see the producers are more in number, so there is a large base, and the top carnivores are less in number, hence there is a narrow tip. Hence, we always get a erect pyramid if you take this terrestrial, that is the grazing food chain, as an example. Now, if you take a parasitic food chain as an example, and we study the number, or that is the ecological pyramid of number, we always get an inverted pyramid. So let's take an example of this a single tree, because in a parasitic food chain, you know that the smaller animals feed on the larger animals without killing it completely. So here we are going to take an example of a single tree. So there is a single tree. So trees are the producers, so they always occupy the bottom of the pyramid. So here, as the number is 1, so its size will be less. Then on this tree there are many birds who feed on the fruits. So the number of birds are more in number, so hence the size increases. That is the second trophic level, the size increases. And on each bird there are large number of these lice and ticks. Hence the number of lice and ticks which feed on the birds, their number is still higher. So here the top of the pyramid is broader and the base of the pyramid is narrower. Hence, in this parasitic food chain, we always get a inverted ecological pyramid of number. Now we shall study the ecological pyramid of biomass. Ecologists propose the idea of pyramid of biomass where the weight of the primary producers form the base. As the term suggests, a pyramid of biomass takes into account for a given unit area the biomass of the producers, the biomass of the herbivores, the biomass of the carnivores, and so on. In the terrestrial grazing food chain and the parasitic food chain, the pyramid of biomass is always upright. The biomass of a grazing food chain, if you take as an example. So let's again go back to the cropland. So here you'll see that the biomass of the cropland is more, hence the base becomes broader. The biomass of the grasshoppers is much lesser, and the biomass of the frogs is still lesser, and the biomass of the snakes is becomes still less because they're still less in number, and the biomass of the hawk is the least in this food chain. Hence here we get a erect pyramid. So this is a grazing food chain, so here we always get a erect pyramid here. Previous example, that is the parasitic food chain, we had seen that the parasitic food chain of number was inverted. But if you take the biomass into consideration, the parasitic food chain also attains a erect pyramid. So here we'll see that the biomass of the tree is in tons. So it occupies the broader base. Then the biomass of the birds will be in kilograms. So that's why it will become less in size. And the biomass of the ticks and lice, it is least, hence it occupies the top and it is least in the weight. Hence, if you take biomass into consideration for the uh, parasitic food chain also. Here also you will get a erect pyramid. But remember, the parasitic food chain of ecological pyramid of number is inverted. But the parasitic food chain ecological pyramid of biomass is erected. Okay, so it is erect here. Aquatic animals. In aquatic animals or in the aquatic ecosystem, the ecological pyramid of biomass becomes inverted. Now let's take an example. Now here, if you consider the biomass of all the phytoplanktons, it is very less. Hence, the base is narrow. Then the biomass of the fishes which feed on the planktons is larger. Hence, it becomes broader. And the biomass of these large fishes which feed on the small fishes, it is much higher. So that's why here the top of the pyramid is much broader and the base of the pyramid is narrower. Hence, if you take the biomass into consideration in an aquatic food chain, we always get an inverted pyramid. Now we shall see the ecological pyramid of energy. The pyramid of energy shows the flow of energy from one trophic level of a community to the next. The shape of the pyramid is always erect because it follows the 10% law, as I had told you in the flow of energy. Now, whenever the energy flows from one trophic level to another trophic level, there is always a decrease in the energy level. That is the reason why the in producers the energy level will be more, and in the successive trophic levels the energy level goes on decreasing. Let it be any kind of food chain. It may be a aquatic food chain, it may be a terrestrial food chain, it may be a parasitic food chain. In all these types of food chain, the ecological pyramid of energy is always a upright pyramid or a erect pyramid. Now let's take an example. Now here you'll see the producers, they are using this solar energy, trapping it and converting that solar energy into food. Now all the energy that is falling on the plant is not used. This I have explained to you in the previous presentation, that is in the flow of energy. That is, out of the 8% of energy that falls on the plant makes use of only 2% and converts it into the food energy. And moreover, all that energy that is present in the plant is not moving into the next level, because some of it is going in form of heat, some of it is used in respiration. Okay, so now when the herbivores, that is the primary consumers, when they feed on the plants, now all the energy that is present in the producers does not enter here, because only 10% of the energy enters into the next trophic level as per the 10% law. And the 90% of the energy that was present here is going out in form of heat. Hence, the energy level decreases in the next trophic level. When the secondary consumers feed on the primary consumers, whatever the energy that was present in the primary consumers, all that doesn't enter into the secondary consumer. Here also 90% of the energy is going out in form of heat. And the top consumers, that is the tertiary consumers, they are getting the least amount of energy, because all the energy that is present here is not going into the tertiary consumers. Here also 90% of the energy is going out in form of heat. Thus, in any type of food chain, the ecological pyramid of energy always attains a upright pyramid or a erect pyramid. Now let us discuss about ecological pyramids and its limitations. These are the diagrammatic illustrations of connection between the different trophic level in terms of energy, biomass and number of an organism. The base of each pyramid represents the producers or the first trophic level. The apex represents the tertiary or the top level consumer. In general, all pyramids are upright, but there are few exceptions. Some important points about ecological pyramids are given under. The first, a given organism may occupy more than one trophic level simultaneously. That is, especially a omnivore. Omnivore may eat the plants and also may eat the animals. So it occupies more than one trophic level simultaneously. The second is the trophic level represents the functional level because all the organisms present in each trophic level, they perform a definite function in an ecosystem and help to maintain and sustain a ecological system. The third, a given species may occupy more than one trophic level in the same ecosystem at the same time. Now let me explain to you, taking an example of the sparrow. Sparrow is a primary consumer when it eats the seeds, fruits and peas, etc. But it becomes a secondary consumer when it eats the insect and worms. Thus, a given species may occupy more than one trophic level in the same ecosystem at the same time. In most ecosystems, all pyramids of number, biomass, energy are upright. That is, producers are more in number and biomass than the herbivores, and the herbivores are more in number and biomass than the carnivores. Thus, in most of the pyramids, all the pyramids are upright except there are some exceptions as we had seen earlier in the parasitic food chain of number and the aquatic food chain, that is the aquatic food chain, taking example of this pyramid of biomass. Here we get inverted pyramids. The fifth important point is energy at lower trophic level is always more than at the higher trophic level. Because in the pyramid of energy, we have seen that whenever the energy moves from one trophic level to another trophic level, there is a loss of energy. Only 10% of the energy moves from the lower trophic level to the next trophic level. That is why the lower trophic levels are having more energy and the upper trophic level is having the lesser energy. Each bar in the energy pyramid indicates the amount of energy present at each trophic level in a given time or annually per unit area. The pyramid of biomass in sea is inverted because the biomass of the fishes is more than that of the planktons. This I have explained to you when we have taken the pyramid of biomass, taking an example of the aquatic ecosystem. Now there are certain limitations of ecological pyramid. Now what are those limitations? The first limitation is it never takes into account the same species belonging to two or more trophic levels. That is, in the ecological pyramid, there is no space for the omnivores. Then the ecological pyramid assumes a simple food chain. That is, in all the examples that we have seen, we took an example of a simple food chain. But in nature, the simple food chain doesn't exist. That is why this is the second limitation of the ecological pyramid. The third ecological is it does not accommodate a food web. Because in nature, always a food web exists. This I have told you in my previous presentation when we had talked about the food web, because the food chains are interconnected to each another. So that is why in a nature always a food web exists, but the ecological pyramid does not accommodate a food web. So that is another limitation of the ecological pyramid. Then another most important limitation is the saprophytes are not given any place in the ecological pyramid. And you know, these parasites, sorry, these saprophytes, they play a very important role in the recycling of nutrients in an ecosystem. And such important saprophytes are not given any place in ecological pyramid. So these are some of the four limitations of ecological pyramid. So with this topic on the ecological pyramid. Thank you for your time. Please take care of your health. And as you know, now there is this second wave of this COVID-19 already spreading in so many other metropolitan cities. Still, it has not advanced, thankfully, in Karnataka. So, my dear students, don't lower your guard. Please take maximum precautions, wear mask whenever necessary, and maintain personal hygiene and eat nutritious food, and take care of your family members also. So once again, thank you very much.